We've been working with order of operations. And now that we've gotten better and better at it, we're going to be introducing exponents into those order of operations. You've seen that a little bit already in your review and preview. We're also going to need to know exponents for our lesson today and how they relate to variables. So that's why we're doing this booster. So let's take this and rewrite it into exponents. What would that be? 3, how many 3s? 2 of them. Then we have our 4, how many 4s? 3 of them. And then we need our multiplication in the middle. We've practiced that before. Now let's go the other way and figure out what this equals. So if you were just given this bottom section, here's what a lot of people pretend to do, or what they do. They do 3 times 2 and 4 times 3. And they forget that exponents are repeated multiplication. So this is wrong. You would not get the right answer. Instead, I need to do where it came from, the 3 times 3. So that equals 9. Ooh, what's 4 to the third? Well, 4 times 4 is 16. Times 4, I don't know that off the top of my head. I'm going to use a calculator. Is 64. Notice it's still multiplied, right? That's what we have in the middle. So we still have to multiply. 9 times 64 is 576. That's what this expression would have equaled. All right, another one. First up, I want you to write out the long version of it. Normally this was our end product. Your turn. Write out the long one. So what is that really representing? And what is that really representing? This means that there's 2 5s. This means that there's 4 3s. And then I can't forget my multiplication symbol in between. It will not always be a multiplication symbol in between. I'm doing that right now because that's what we've seen before. Now let's figure out the answer. Take a second and figure out what each of the terms would be. What would those equal? Well, actually, I probably shouldn't. We should go in order, shouldn't we? Multiplication goes left to right. I'm not going to simplify it that way. Let's just type it into a calculator. So we would do 5 times 5 times 3 times 3 times 3 times 3. So 5 times 5 times 3 times 3 times 3 times 3. 2,025. That would be our answer. All right. One more. Let's do okay. Notice I've changed it a little and I didn't put a multiplication, I put an addition. Really, nothing changes. We still can rewrite that into being 3 times 3. We can rewrite that to being 4 times 4. Because, remember that 2 says how many 4s. It's not 2 times 4, it's how many 4s. Then I would just put my addition in between. This would be 9. This would be 16. I bring that plus sign down. Then I can just add them up. And I would get 25 in this situation. Okay, now that we've seen that a couple times, what would happen? I'll use a different letter. If I had that, how would I rewrite that with exponents? If it helps you to think, how would you rewrite that with exponents? Go for it. It's the same pattern. That would be 3 squared, right? This would be n squared because the 2 just tells me how many n's are used. So that would be n squared. Crazy, right? Let's do another example like that. What would this be with exponents? Okay, there's 3 4s, so it's 4 to the third. Use that same pattern. What's that one? Yep, n, and there's 3 n's. We don't know what n is. That's okay, we don't need to know. We're allowed to just write a variable and how many variables. Then eventually when we do get what n equals, then we'll be able to solve it. Let's pretend that magically you have been told what n equals. N equals 2. All right, what would I do if n equaled 2? That means that it's 2 to the third, right? And that means each of these is going to become a 2. That just means 2 times 2 times 2. 2 times 2 is 4, times 2 again is 8. So don't get weirded out if you see a letter that has an exponent on it. It's really no different than a number with an exponent on it. It just means you can't solve it right away until you get what the number equals. What if I had this? You know what? No, I'm going to save that for another day. Okay, that's enough for now. That's it. Adios.